My name is Liz Schlemer, and this is a video for IME 443 Facilities Planning and Design at Cal Poly San Luis Obispo. This particular video covers space requirements, particularly around line balancing. In this video, we're going to talk quite a bit about excellent engineering and the quantitative approach to determining the number of workstations. But we always are aiming to do this within a context of a project or a company concerned about social issues and environmental concerns. Facilities planning covers many these particular topics, and we are in the area of layout design, and we're talking through this systematic approach, spending some time in determining space requirements. This is the third video in determining space requirements, particularly around the number of workstations, and we're going to be covering line balancing. So in line balancing, the goal is that you would have smooth production to meet demand. And there wouldn't be bottlenecks, or there wouldn't be a lot of idle machines or workers. So in this case, we try to determine the appropriate tasks for each workstations, and we also try to determine the appropriate number of workstations. So what we start with is this thing called takt time. It's the time that a component spends at each workstation, and it's dictated by demand. It's expressed in minutes per workstation, and the idea of takt time actually has to do with the beating of a drum, that you would be processing something for a certain amount of time and then it would be passed to the next workstation. The calculation is actually minutes available per day divided by the demand, minutes available per year divided by the demand per year, or it could be per day as long as they match, but it'll end up being minutes per item. So as an example, if we look at this pretty complex operation process chart, it does show you all the different things that need to be done and the minutes that it takes to do it. And this example, we're just going to look at takt time initially, but a table manufacturer wants to produce the following tables and calculate the takt time if demand is 2,300 units per year. The company works one shift a day. So the question is, what is the takt time? So what we do is we take the total production, which is 23,000 units, and we look at the total available time, which is 8 hours a day, 5 days a week, 50 weeks a year, which is 120,000 units. We divide that out, and it's a little bit less than a minute per unit that something needs to stay in a workstation. So as we, whenever we're doing the calculations of line balancing, we always want to kind of measure what we're doing by this expression of efficiency. It's expressed as a percentage, and typically over 80% is pretty good. So the way we calculate this is that we add all of the task times in a particular department, and we say this is all the work that needs to be done, and then we divide that by the takt time, which is the time that it spends in each workstation, times the number of workstations. And this will give us an expression sort of work time to total time. So there's two situations that we need to be concerned about where the tasks times are greater than the takt time. And in this case, we'll use multiple workstations to do each task. So if you remember in the last example, it took about a minute. The takt time needed to be a minute, but some of the tasks are longer than a minute. So what we do is we have multiple workstations working on the same task that then will decrease the amount of time it needs to spend in the workstation, or that it'll increase the frequency at which things are done out of the workstation. So as an example, we have a demand for 340 units in an 8-hour workday. What is the required takt time in minutes? And how many people should perform each of these tasks in order to produce the required parts and to balance the line? So we have all of these times. The first thing we want to do is to calculate the takt time. So we take the 480 minutes that we have, which is an 8-hour workday times 60 minutes, divided by 340, which is 1.41 minutes per unit. So if one person's working on that, it'll be 1.41. If two people, then we can spend 2.82. If it's three, 4.323. So when we look at each of the task times, we can look at the various task times and say, well, should one person be doing that? If it's less than 1.4 minutes, they can be doing that. Two people can do it if it's less than 2.8. and 3 people if it's less than 4.2. So you can see I've assigned 1 person to do task 1, 2 to do task 2, 2 to do task 3, etc. And that means there's a total of 38 workstations going on here. And then we can calculate the efficiency, where we add up all of the times, that's 16.37, and we then calculate the 13 workstations time to task times, and we divide that into 1637, and it's an 89.3% efficiency. That's pretty good efficiency in this design. So the next example is if task time is less than takt time, which means we can group tasks together into workstations. So if we're going to do that, we need to understand the precedence. So we're going to group tasks into workstations such that the time in each workstation is less than the takt time, and then we'll calculate efficiency again. So I'm going to go through an example as a way of illustrating this. So we're going to group multiple tasks into workstations, and in this example we're going to produce 300 units in a 450 minutes. What's the takt time? And then given the precedence, which task should be assigned to each workstation, and what is the efficiency? So what we've done here is I've gone through and drawn these precedents. You can see on the right-hand side of that table, it tells you each task and what needs to be coming before that. So for instance, tasks A and B have to come before C, which I've drawn it that way. And then I'm going to calculate takt time, which is 450 minutes divided by 300 parts. I've also included in these circles the time to produce that task. So you can see then if I group these together, and these together, and these together, and this by itself, and this by itself, and these together, that all of those sum up to less than 1.5 minutes, and that's 6 workstations. So I can then now calculate the total, efficiency. I add up all those times, divide it by 6 times the takt time, and I get a 73.4% efficiency for this design. Now that you have the number of workstations, either by grouping tasks together or having multiple workstations, you can then move on to determine the space requirements for the departments.